Okay, now tutorial. So yeah. Okay, so if you go through this tutorial, I think almost every question is about ERD diagrams. There's no homework this week. I'll do this everything, and then I will demonstrate how to construct ERD diagrams. Okay, let's go through the first question. Now, what they ask us to do here to create an ERD solution based on this narrative, right? So how do you create the ERD? What is the first step, right? Now, remember in week 6 lecture, slide number 8, I have discussed the steps involved in ERD design, right? These 9 steps. You can follow these steps. Or maybe I mean, if you have a bit of experience, probably you can jump straight to maybe step 3. Okay, so yeah, so just remember that slide number 8, week 6 lecture. Okay, so let's go through this. Now let's read the narrative. Now the first step is we need to identify the strong. Now it's very easy if you can identify the strong entities and attributes. Then you can kind of see a kind of a link between these entities, and then everything else will come along that way. Okay. All right. Now let's read this. Now it says the Curious database group has about 120 employees. Now they are talking about employees in this company. Each employee has an ID, a first name, and a surname. Okay. Now when you read this sentence, so they're talking about kind of an employees, and now when you read this sentence, so you should be able to aha, looks like kind of a some kind of an object that we need to represent in our database, right? So employees looks like an object, right? And then they discuss some sort of an attributes related to that object, right? IDs, first names, surnames looks like an attribute. They are the attributes or characteristics of this object. So the employee looks like kind of an entity, right? What kind of entity the employee now? What is the entity type? Is it a strong entity or is it a weak entity? So that's the next step. So when you read this, you can see each employee has an ID. So that means each employee we can uniquely identify by using these IDs, isn't it? So that means employee looks like a kind of a strong object or strong entity. So we can actually capture that. And then the other thing is this company names. Do we need to have an entity for this company name? Yes or no? No, right? Why? What is the reason? Why don't we need a kind of an entity for this? Because the reason is what? Reason is we don't have more than one instance of that, right? So we don't need a kind of an entity to record the organization's name, right? So we don't need to actually, we can forget about it. So we have now one entity called employee, bunch of attributes, and then ID can be what do you call its identifier, right? And then it says each employee belongs to the departments, right? Department. The organization has around 6 departments, right? Each department has a department codes and the department names. So when you read these 2 sentences, you should know, right, they are talking about another object called the department, right? And the department, probably an object because they can have 6 instances. It says 6 departments are there, right? And each department has department codes and the names are right. These are the characteristics of the department. Or in other words, these are the attributes of the department, right? So now we have a kind of a relationship between these two. Yeah, employees employed by the departments. Now we can kind of have an idea, right, how this works, right? So what we can do is straight away we can go to, now I am using is what you call paint program. Now you can use diagrams.net, right? You need to actually use that program. I remember I demonstrated it before. For simplicity purpose, I'm using this. Okay. Right, now let's draw this. So what we can do is straight away capture these two objects, right? Okay. So we have two objects, right? One is employee, one is department, right? So let's um, capture that. So employees and the department, right? And then we have some attributes. So let's capture the attributes. So the department, so the employees, we have how many attributes? ID, first name, and the surname. So there are three attributes. So one, two, three, right? So let's name these attributes. So this is empid, and the first name and the last name. I just put F name and L name. So we can straight away identify the primary key. Yeah. So identify the primary key, that's the ID. And then let's come to this one. So how many attributes we have? Department code and the department names. So let's name this the code and the name. By the way, department, what kind of entity is this? Is it a strong entity or a weak entity? What do you think? This one. It's a strong entity. Yeah, why it is a strong entity? Because each department has a unique codes, right? So we can easily identify each row by going through these codes. Yeah, isn't it? Ash, it's no, my advice is, so good question, Ash. So what your question is it a good practice to write the relational schema first to draw the ERD? No, my advice is to create this model first. This is easy, right? If you create this model, because then you can get a kind of an idea how your entities are related to each other. Because straight away, if you create a relational schema, it's not that visible. If you have a kind of a some kind of a diagrams in front of you, you can actually translate it to relational schema very easily, right? So my advice, I actually never done that. Some people actually do the relational schema straight away, but I haven't done that. Like, to be honest, I'm more comfortable designing this model first, and then sometimes I need to go back and do some modification, and then I can fine tune this model, and then I finally do the relational schema. Okay. So what will happen if you do the design the relation schema? If you made a some kind of a mistake somewhere, probably it may not visible until you design all your tables. Then it's too much of work. You need to come back and then redo the work. Okay. So my advice is to first create this model, and then step 2 is to create relational schema, hash, right? Does it make sense? Um, uh, no, the what I mentioned in one of the thing is because once now ERD design, you can make modification. That's fine, right? What I have mentioned here, there, I guess sometimes people, are reluctant to change their, the model once they have designed it, right? So usually, what we do once we design it, it's we It's actually a team effort. It's not a one person effort. It's a team effort. So we do kind of a brainstorming, and then we uh, change the model with some, if we can get some more details, or the models can be changed. And then finally we do the relational scheme. Uh, that's how we do usually. All right. Um, yeah. So what I have mentioned, Ash, I guess sometimes we can create. Now, for example, some models are very complex, right? So we create shorter version, like we remove all we don't create all these weak entities, but we create all the strong entities first. Uh, and then we expand it by little, right? And then finally we that's what I think I have mentioned in that. But yeah, so let me know which slide I have talked about that. I'll revisit it and explain it. Okay, Ash, let me know which slide. I can't remember. But normally this is what we do. First ERD diagram, and then relational schema. Okay. All right. So back to this. Okay, so the department now looks like a strong entity. Okay. Right. So what does it mean? So that we have employees, right? And we have departments. So what this looks like, there's a relationship, isn't it? There's a relationship between two strong entities. Okay. So how do we create this now? How do we going to link this with? How do we going to demonstrate cardinalities now? If you think about left to right, it looks like it's more logical to assume a department can have employees, right? Department employed employees, right? So one department may employ multiple employees, isn't it? Right? So we can actually now see a kind of a link. That's what it actually assumes here. Organization has 6 departments. Each employee belongs to a department, right? So each employee must belong to one department. Because if you have an employee, it must belong to one department. You can't have employees without belongs to any department, right? So it must. So that's the participation constraint. Okay. So that means department code goes to employee as a foreign key, right? So we have an extra column here, department code. So that foreign key must have a value associated with this primary key. That's what we mean by this extra one here. Okay. So now I can put a kind of a relationship here. Maybe we can say um, can put just 4. A department for employees, for department, or department recruits employees, and just put any relationship name, but don't underline it, right? Don't underline it, because if you underline it, what do you mean by underline? If you underline it means we are grabbing this department code as a part of a primary key here, then it will become a weak entity. So we don't want that to happen, right? Because we already have its own primary key. So we don't need to actually grab this department code as part of the primary key for the employee, right? So no underline. So this is looks like the final version for this small context. So now we can actually write the relational schema very easy, right? So now what is the first? Which entity we need to create first? Which one I need to create first based on this model? Is it the employee or is it the department? Department. Yes, that's right. So department, uh, the code, the name, right? That's and then I can say primary key is the code. And then I can come to the next one, employee, right? So we have emp ID, comma, first name, comma, last name, uh, comma, department code, right? And then I can say primary key for this entity is emp ID, and the foreign key is department code. References department. Right, so that's the, it's easy, isn't it? By looking at this to create the relational schema, very easy. Actually, what is the next step? Once we create this relational schema, what is the next step? We create the table. Create table, department, bracket, and then we specify all the columns. We code, maybe what, you can say 5 or whatever, and then we need maybe you can say 20, and then primary key, the code. Right. So likewise, we can create the tables very easy, right? So this is step 1, this is step 2, and this is step 3. Ash, now does it make sense? Because if you create this, if you made a mistake, then it's very difficult, So it's very easy, isn't it? If you have some visual diagram first, so we can easily create. Now we know that each, when you create an employee table, now remember the department code is a foreign key, and it needs to be not null, right? Because you can't have null values there. So you can put a not null. So for example, here, if you have create table employee, right, and then we have all these uh, other attributes, and then we have the code, right? Department code, say varchar, varchar 5. So we can say, okay, it's not null. Not null because we have the not null constraint here. Right. So that's the answer actually. That's the answer. Are you all clear with that? This question? Everyone. I want everyone's answer. Because this knowledge is really important for the next assessment, the case study. Okay, so you guys are designing a database from a scratch, right? From a scratch. I give you the information. You need to design this. You need to write the relational schema. You need to implement it, writing create table statement, and then you need to write bunch of SQL statement or queries to give answers to some of the questions I am asking. Okay. So this knowledge is very important. All right. Okay, how about the next one? Next question. So let's go to the next question. Now, so let's read this. The Atomic Primary School wishes to democratically choose which animal will become the school's mascot. The list of alternatives includes kangaroos, koalas, tigers, elephant, penguins, etc., etc. Each student may vote for one or more of the animals to be the mascot. Okay. Each student has a student ID and a name. Each of the animals has been assigned a numeric ID and a name. Example number 7 is a tiger. The school wants to be able to store all of the votes made by the students in the database. Right. Okay. So create an ERD solution based on the above narrative. Okay. So more narrative. So the first thing first, when you read it, you need to actually try to grab all the strong entities. So what are the strong entities can you see in this small narrative? Anybody who can answer this? What strong entities do you think you can visualize from this narrative? So strong entities are nouns, right? If you pinpoint all the nouns, some nouns actually give you a kind of an idea. Strong entities, right? Yeah. So primary school, now atomic primary school, obviously it's not an entity, right? We have only one instance or one record, so we can ignore that. And they're talking about animals. Yes. So Ash says animals. Looks like an animal is a good candidate for primary, a strong entity because it says we have list of animals, yeah, kangaroos, etc., etc. And then and they are talking about what students, right? Okay, and students are voting for the animals to be mascot. Each student has a student ID and the name. Looks like a student. He looks like another entity. If they are talking about some attributes or some characteristics of the student, okay, so definitely student is a entity, right? And then they have talking about animals, the characteristics of animals, numeric IDs and the names of the animal, etc., etc. So definitely animal and the student looks like two entities. In fact, they actually looks like two strong entities, isn't it? Because animals also have a unique IDs and students also have student IDs, right? So the both entities looks like a strong entities. So the same theory like this, right? So we have students, we have animals now. Okay, so let's do that. Okay, so what I will do is now I will make a kind of a I don't save it. Okay, I'll take a new one. So let's capture the information presented here. So we have students, we have animals, right? So student and animal, and then we have bunch of attributes. Student has student IDs and their names, I guess, yes. And then the animals also have their IDs and animal names. So let's capture that. So student ID is, I just name it as SID, and each student has their names. So student name. So let me underline SID. This looks like a identifier. So it's a strong entity anyway. And here the animals also have a unique IDs, right? So I can say this is my animal ID, and also animals have names, animal name. Right, so let's underline animal ID, looks like another strong entity. Okay, so now we have a relationship, right? Now students are voting for the animals. That's what it says, right? Student actually vote more than one animal. So one student can vote. Uh, so if you have a relationship, so what it says, one student can actually vote for many animals, and one animal can be get voted by multiple students, isn't it? So looks like a many-to-many relationship here, right? Where an animal can get multiple votes from different students, yeah. So there is a one-to-many relationship from right to left. and also one student can vote for multiple animals, right? That's what it says. So there is a one-to-many relationship between um, left to right in this model. So that means it looks like a many-to-many relationship. Now, if you have many-to-many relationship, what's the what we need to do? We need to remove this, right? We can't live with this model because relational database systems, this model actually very hard to implement, right? I think I have explained the reason. So what we need to do, we need to get rid of uh, these many ends, or actually I take off this line. So what we need to do is we need to create a weak entity, right? So we need to create a weak entity in the middle. Okay. And once you create the weak entity, what will happen to the many ends? Many ends need to be reversed towards the weak entity sides. So this many end reversing towards the here, and this many end reverse towards here. Okay. Okay. So let's actually uh, write that first. So many end, and one here and one here. Right, now we can get a kind of an idea. Now what we are going to actually record here, anybody who can uh, tell me the answer. What is actually we are recording here? Yes, Ash, we are good. Vote. This is the vote, right? We are writing the votes. Now votes, we are recording the votes. So this student vote for this animal, right? Can be recorded here. So, so how do we, what is the idea, what are the attributes here in this case? What do you think? What do you mean by the actually vote? How do we know the vote? So if I know the student ID and animal ID in combine, the student, this animal, that's actually a perfect combination to count a vote for a particular animal, isn't it? So that means if I grab these two from these both ends to this entity, right, then that would be a perfect information to count as a vote. And also it's a perfect combination to create a primary key for this entity as well, isn't it? If I combine student ID and animal ID. Actually, that also satisfies some business rule because one student can't uh, vote for the same animals twice, right? That makes sense, right? So if I combine these two together, yeah. So that means I can actually underline the relationship names. Okay. Now remember we have already done this kind of model before during our tutorial or the lecture. Remember we have movies, we have a actors, and then we have casting entity in the middle. So actors are casting in different movies. So same principle applies here. Students are voting for different animals. Right. Now can you see kind of a relationship? Because you will see these sort of models can represent in different contexts. So if you know the logic, it's simply application of that logic into that particular context, right? So now I can say, okay, students, maybe we can give any relationship. Maybe we can say student makes votes, right, for the animals. Right. So if I write the relational schema, okay, now I can, sorry, I just forgot to put now participation constraint or the cardinality constraints here, or participation constraint. So I can put an extra one there. Sure. And 0 and 0 here. Because students may vote for animals, because there may be students that not voting at all, right? They don't want to vote. And also there can be animals that we don't actually count any votes, right? It not necessarily each animal get voted, right? So may, this is also may. Right. So now we can easily convert this model to the relational schema, right? So maybe we can first write student, or maybe we can first write the animal. It doesn't matter because both are strong entities. So if I write the student first, student, I can write student. These are the attributes, student ID and student name. This is the primary key, right? And then um, animal. Um, these are the attributes, animal ID and animal name, right? Primary key is animal ID, and then the last one is okay, I'll take this here. The last one is the vote. Vote. So the vote. So we know that there are two columns here: animal ID and student ID. And the primary key also animal ID and student ID. Uh, and also these two will become foreign keys as well. So foreign key 1, animal ID, references animal, foreign key 2, student ID, references student. Yeah, does it make sense? Right? Now this is the relational scheme. Now we can write the create table statement based on this. And then in that create table statement, make sure we put because if you have vote, that vote must represent student and the animal, because we don't need to actually put not null, because anyway in the vote entity, both of these foreign keys will become a kind of a primary keys as well. So that means it's almost not null, right? It implies not null. So we don't need to put not null there. Anyway. All right, that's about it. So how do you feel now? Do it make sense now for the second one, second question answer? Are you all okay with the answer for the question number 2, guys? Any questions? All okay, all good? So hi is yeah, Doris, Arshun, Ash is okay, I think. Abdul Aziz, John, Kevin, Kim, all good. Nicola, Will, Stitiver. Yeah. Does it make sense? Okay. I always ask you guys because I want everybody in the same page. Okay. We don't want to rush these things, right? So we'll go very slowly. Okay. Anyway, the test is there, so don't worry. So all right. Now let's come to question number 3. Okay. Now question 3. So the Melbourne Sudoku Championships are about to take place. The number of competitors will compete in the championships. Each competitor has a unique competitor ID and the name. Alright, now when you read that sentence, you should be able to answer, aha, they're talking about ID and the name looks like attributes of something, right? Attributes of competitors, right? So looks like competitor looks like a kind of a strong entity, right? A number of Sudoku puzzles have been generated for the championships. Each puzzle has a unique number and the grade, such as easy, hard, diabolical. Alright, so when read that, looks like they're talking about other attributes, bunch of attributes for a puzzle. Looks like a puzzle now become kind of another entity, right? In fact, it looks like a strong entity because each puzzle has a unique number, right? Now we have an idea, right? They're talking about computers, they're talking about puzzles, right? So now we can see a kind of an idea, right? So computers can be attempt different puzzles. That's what it looks like, yeah. Right. So they have given us a kind of an example here. Puzzle number P2222 grade is hard example, right? So during the championship, puzzle will be given to a number of competitors, right? So that means one puzzle can be actually undertaken by multiple competitors. There's no restriction. And each competitor competes a puzzle. His or her time is recorded. Okay, right. Competitor competes the puzzle. So we need to record the time that it has taken, right? So the organizers of the championships want to be able to produce a report such as this. That's the report they're expecting. So the competitor IDs, names of the competitors, puzzle IDs, and the puzzle, what do you call this, puzzle grades, and the time it has been taken for each puzzle, each competitor, right? And yeah, so this is the report they like to produce. So in order to produce this report, what type of how our database looks like. Now, when you read this, now they're talking about competitors, puzzles, and they are attempting these puzzles, different competitors. It actually looks like again the same model, right? It looks like the same model. So we have competitors, we have puzzles, competitors are undertaking puzzles, right? So again, the same model lurking here as well, right? So let's actually now let me take a new. So let's actually capture that information now, right? So same theory again. So we have competitors, we have puzzles here, right? So let's capture these two first. Competitor. Here is the puzzle. Um, puzzle. Oops, puzzle. Right, so we have a bunch of attributes in each of these. So we have completed, I think, ID and competitor names. So two attributes here. And for the puzzles also, they have puzzle number or puzzle ID and the grades. So two attributes here. Right, so let's write these attributes. Complete ID, I just find it as CID, and competitor name is CNAME. And again, here we have puzzle ID, PID, and then we have puzzle grades. Grade. Right, so let's underline the keys here. So looks like complete ID looks like entity. Oops, it's gone. Give me a 1 minute, guys. I need to just give me a 1 minute. I think it's gone. Oops. Sometimes my computer getting uh, all right, let's come back. Okay, so the PID looks like another primary key for the puzzle. Right, so now we have a relationship, isn't it? Competitors undertake the puzzles, right? So one competitor can undertake how many puzzles? Is there any restrictions here? No, right? It says number of Sudoku puzzles have generated for the championship. Um, right. So during the championship, the puzzle will be given to a number of competitors. Each competitor competes a puzzle his or her time recorded. Right. So if you think about one competitor, how many puzzles they can compete? Is there any restriction? Can we see any restriction here? Competitor ID. Now we can see the Peter Jones actually taking two types of puzzles. So that means there is no restriction between the competitor and the puzzle, right? So one to many, right? It's a one to many relationship between the competitor and the puzzle. Right? Then one puzzle can undertaken by multiple competitors as well. There is no restriction as here, isn't it? Because you can see um, puzzle P2222 undertaken by multiple competitors, right? So there is no restriction between these two. So it looks like a many-to-many relationship, right? Again, many-to-many. So if you have many-to-many relationship, so what is the rule? You need to create a weak entity in the middle. Okay, let's create the weak entity now, straight away. So this is my weak entity. Okay. So that's my weak entity. Just delete this one, sorry. Right, so weak entity means the many end. We need to reverse back to the weak entity. Yeah, right. So one to many, one to many. Right. Now my next question is actually what we are going to record in this weak entity. Any idea? So competitors undertake puzzles, but then we need to record what for each puzzle. Each puzzle we need to record the time, right? So that means what is this weak entity means? What is this weak entity? Any idea? What is the name? Any name you can give? Time. Ash, I guess time is an attribute, isn't it? Because each computer undertake puzzle, we need to record the time. Yeah, time is a kind of a uh, attribute. Time. So this is actually an attempt, isn't it? Each competitor's attempt, right? Each attempt has a time. Am I right? So the best name that we can give here is attempt, right? So that means each attempt has a time. Okay. So now this weekend it has its own attribute, actually time attribute. So but what is the identifier for this attempt? How do we know these attempts belong to this competitor and this puzzle? So what we can do is simply take competitor ID and puzzle ID as an identifier or composite identifier, right? Okay. Does it make sense, guys? So if I underline the relationships in both directions, so I can make a kind of a perfect identifier for this weak entity, right? So I can say here, computers has attempts, puzzles, maybe you can say has as well. Right, so how many attributes now we have in attempt entity? Three attributes: competitor ID, puzzle ID, and the time. Competitor ID, puzzle ID actually act as a primary key, as well as their foreign keys as well. Okay. Right, so that's about this question. So now can we produce this report based on this model? That's my next question. So if I want to produce this report, compute ID, name column, parcel column, grade column, time column, yes, I can, because all the information is there, right? So you can see the computed ID comes from this entity, computed name comes from here, and the parcel details come from here, and the time taken in each parcel by each computer come from here. So if I combine these three in a select statement, select CID, C name, right, time, PID grade from competitor, then maybe we can put an inner join or left outer join, time, and then we have another left outer join or inner join with parcel. Okay, so we can easily produce this report by having this, by combining these three entities. By the way, all right, does it make sense? How about everyone? Are you okay with this model? So now you can easily write the relational schema, first the competitor and then the parcel and then the finally the attempt, right? Okay, do you have any questions regarding this model? If not, we can actually move to the next question. All good? Okay, looks like everything okay. Okay, how about this question? Now question 4, question 5, and question 6 and 7. All, I guess, uh, is a one kind of a big narrative, but small parts. Okay, now let's go through this. Sweeney Publishing encouraged staff to write textbooks for the university subjects. Each textbook has a title and a unique ISBN code. Right, when you read this sentence, you should be able to identify, they are talking about some attributes of subjects. Right. Each author has a first name, surname, right? Again, authors, right? They have a first name and surnames, looks like another entity with bunch of attributes. Assume that no two authors have the same name. Each book written has a single author. Right. Authors often complete 2 or 3 books in a year. Right. So each book has written a single author. Okay. All right. Sweeney Publishing want to be able to produce a report such as this. So ISBN code, the title, author IDs, and author names. Right, so they ask us to draw an ERD for the above situation. Show the example. Okay. All right, now how this looks very simple. Now let's actually draw the diagram first. So I'll take a new file. So again, my first question is how many entities you can see from this small narrative. So they're talking about subjects, they're talking about authors, right? And they are talking about Sweeney Publishing. So definitely Sweeney Publishing is not an entity. We have only one instance of that, so we don't need to actually take it as an entity. But of course, we need the subject entity and author entity because they are talking about subject. Uh, uh, Authors are writing subjects or the textbooks, right? Or sorry, not the subject, maybe textbook is an entity, right? Because authors are writing textbooks for different subjects. So we have 2 entities now, author entity and textbook entity, right? So let's capture that first. Okay, so I just write it here, author, and just write there the textbook, author, and here the textbook. Right, so they're talking about some attributes of each of these entities, right? So we can capture that very easily. So authors, they have author IDs and no, they don't have author ID actually. But if you go to this sample output, they have actually mentioned the author ID. So that means we can assume they have author IDs, right? And then authors have the first name and the surname. So that means we have three attributes there. Okay. And then for the textbooks, they have textbooks IDs and the textbooks names. So textbooks ID is the ISBN number, right? ISBN number. All right. Okay. Okay. So authors and the textbooks. Okay. Now let's actually write down this author, author ID, and then we have author's first name. I just put F name and author's surname. So I just put L name, last name. Okay. And here we have ISBN number, and then we have textbook title, right? Right. Okay. So now we can actually easily link these two because authors are writing textbooks. So one author can write how many textbooks according to here. Do we have any restrictions? So you can see that Peter Joshua is written two books here, right? So that means one author can actually write multiple textbooks or maybe writing multiple textbooks. So one, two, many. But if you think about one textbook, how many authors contributed to each textbook? There is a business rule. It says each textbooks, there is no two authors have the same name. Okay, name. Each book has written has a single author. So one textbook is written by one author, right? So that means there is no many-to-many relationship between these two. So there is only one-to-many relationship, isn't it? One-to-many. So we have two strong entities, but with one-to-many relationship, right? So if I put one, because I need to put another extra one here because the author must appear in the textbook. So the author name, author ID, sorry, author ID is a primary key. It appears in the textbook entity as a foreign key, and it has to be not null, right? Because we need to know, we must know the author ID for each textbooks. Okay. So this is the model actually. Okay. This is the answer for this. So can we now produce this report? Yes. You can see the ISBN code and the titles coming from this entity. Both IDs and the names are coming from this entity. So if I run a select statement with inner join, we can easily produce this report. Yeah. Yeah, so that's the model. We can write a kind of, yeah, we need to actually provide a relationship here. So we just put has, authors has textbooks. All right. Does it make sense, guys? This model, this model to represent this narrative. Yeah. Okay. Okay. Now let's go to the next one. Now you can actually generate. You can give some sample data based on this, right? For each entity, I think it's not that difficult. Right. The next question actually is extension of the same uh, scenario. So the business narrative for the previous problem has now been changed slightly. Any of the textbook published by the Sweeney Publishing could have now multiple authors. What do you mean by that? So earlier one author can write in multiple textbook, and one textbook can only have one author. But now each textbook can be written by multiple authors. So that means now, okay, now what happens? Sorry. One textbook can be written by multiple authors. So that means there's a many n comes here, right? So looks like many to many relationship. Yeah, that's what it says. Now, if we have many to many relationship, can we live with this model? No, right? We have to remove this and create a weak entity in the middle. Okay, that's what we need to do. So straight away we can actually remove this and make a weak entity in the middle. Okay, let's make a weak entity now. Um, so I just put a weak entity here. Right, and then write the relationship, and then reverse the many n towards the weak entity side. So now we have two one-to-many relationship. Okay. All right. So what is this actually weak entity we are trying to record? What information we are trying to record here? What information we are going to record here? Any idea? Any idea what we are going to record in there? Anyone who can answer that question? So we have authors, we have textbooks, but here we are actually recording what? Which author has contributed to which textbook, isn't it? Each author contributed to which textbook. That's what we are trying to record here. Yeah. So we can actually rename, or you can name this as, maybe you can do authored, right? So if I take the author ID and the ISBN code, right? If I record that there in combine, I can easily know which author contributed to which textbook. Okay, isn't it? So the title, Doris, the title is already there. So this actually record the author who authored which textbook. That's the information record in this entity, right? So that means what is the primary key for the authored entity? Author ID and the ISBN code, right? So that means if I borrow these two from both ends, I can make a kind of a perfect identifier, and these are the only two attributes we have in this authored entity, right? So I can complete this. I just put some weird relationship names. Put has, and then put extra one here. Uh, uh, Zeros there because we can have authors which have authored any books. That's perfectly okay. Uh, but textbooks, actually here we need to have one, because one textbook must have one or many authors. Okay. Right, that's the model actually. Now can we produce this report based on this model? Let's see, ISBN codes, yes, it's come from here. Title, it's come from here, right? Both IDs come from there, and also it sits in here as well as a foreign key. And the names of the authors, yeah, it's already there. So if I can combine these three entities, I can produce this report. So what this report means, it actually tells which textbooks authored by which author. Okay, does it make sense, guys? Sorry, do we have any questions? I think Doris, I have answered your question already. So does it make sense now? Yes or no? Yeah, everyone. I want everyone's answer. Yeah, because I don't know whether you got this concept correctly. Yeah. Please let me know if you can't understand, all right? I want every single student in my class get these concepts correctly, right? If you don't, let me know. Right, Ash, I was confused at the first, but then I realized you were doing question. Yeah, question 5, because it looks same, it's an extension of question 4. So question 4, and then we extended some little bit more information. Actually, more information because they have changed the business rule. Yeah, earlier only one single author, but now multiple authors in a one single textbook. That's the only difference. That's why we have this weak entity. Yeah, right. So now we are going to question 6. Then again, little changes to the existing model. Right. Ready to go? Okay. So let's read this one. The business narrative for the previous problem has changed again. The university has a number of books, generally one at each campus, right? All right, now they're talking about the campuses. Each bookshop has a unique ID, right? So, so they're talking about number of multiple bookshops, right? Each bookshop has a unique ID, such as Hawthorne, Lilydale, Prahan, etc., etc., plus a manager name. Okay, so that means each bookshop has a manager, right? Before the beginning of each semester, each bookshop orders a number of books from Swinning Press. The system must record the date of the order, the quantity of books that were ordered, and the date of the books were delivered. Alright, so these are the information related to the order that we need to capture and record. Okay. So each order has a unique ID number. Each order has a unique ID number. So that means order looks like an object with unique ID. That means it looks like a strong entity, right? An order, because it says it has a unique ID. Only one book may be ordered on an order. Okay, that's the business rule. So that means if I wanted to order 5 books, I need to place 5 orders, separate 5 orders. Each order has unique ID number. That's what it means, right? Okay. Right. So Sweeney Publishing want to be able to produce a report such as this. So order number or the order ID, which bookshop that has been ordered, ISBN codes, the date the book has been ordered, number of books in each order, right, or quantities, and then the date delivered. You can see the date delivered. You can have null values, right? Okay, now how can we, right? So they are want us to redraw the ERD, right? So actually we can modify this one a little bit, or maybe we can add some info to there. So we already have this, right? Authors, textbooks, and author, right? So I don't think there is changes into this. But now they says there are a number of bookshops who are trying to take these textbooks as their uh, inventories. right? Then, so they are talking about bookshops, right? So we can actually, now they're talking about bookshops here. Now, what is bookshop? Is it a strong entity or a weak entity? What do you think? Bookshop. Each bookshop has a unique ID, right? The name of the suburb is the bookshop ID, right? So that means bookshop is a strong entity. Yeah. So let's capture that first. So that's the easiest part. So let's write, okay, so we have the bookshop here. So we can write, okay, bookshop. So looks like a strong entity. So we have attributes, bookshop ID, and what else? And each bookshop has a manager, right? So manager's name is also another attribute of the bookshop. So bookshop ID. So I just put BSID, bookshop ID, and the manager name. So MGR name. Okay. Right. So strong entity. So primary key is bookshop ID. Right. So bookshops are placing orders for the textbooks. Right. So bookshops placing orders for the textbooks. So that's the relationship, right? This relationship. So that means there is an order entity as well, right? Um, because they says each order has a unique ID, right? That's what it says, right? Uh, okay. So date for each book, each order has a unique ID, right? So looks like there is another strong entity called an order. So let's capture that order. Order. And then there is a relationship between the bookshop and the order and the textbook. Bookshop ordering textbooks, right? Makes sense. Right, so now let's capture the attributes of the order. That would be very easy for us. So what are the attributes? They have given here the date of right order ID, order ID, the date, quantity, and the date delivered, right? So there are a bunch of attributes actually. One thing like there are four, two, three, four. Uh, order ID. So I just put OID there, okay. And then we have order date. I just put O date. And then the third one is the quantity of the books because each order for a one book, yeah. And so that means it makes sense. Put the quantity there. And then the date. So do we know the date ordered? Yeah, so date ordered is also there. Right now here you can see date ordered, date delivered. There are two more actually. So this is order date, and then there's one more attribute, date delivered. Um, so that's the date. Okay. So the primary key obviously order ID, right? So now we can see the cardinalities. So one bookshop can make multiple orders. So one too many. So one too many, right? And then each order is for how many books? One textbook, yeah. Each order is represented by one textbook. But one textbook can be ordered by multiple orders by multiple bookshops. So many and attached here as well. Right. So there is a two strong entities now, right? Actually, four strong entities in the entire model. So bookshop, order, textbook, author, all are strong entities. Right? So I can put now cardinalities and participation constraints. Um, so yeah, so that's so then I can put a kind of relationship names as well. So I just can bookshops makes orders for textbooks, right? So don't underline because we don't need to underline because it's a strong entity. So in this strong entity, order entity, we have two foreign keys, right? Bookshop ID and ISBN code. Okay? But they are not part of the primary key. They just sits there as a foreign key. So the primary key is the order ID, right? So can we now produce this report based on our mod? Order numbers, yes, here bookshop names, oh sorry, bookshop ID, right? This is bookshop ID is there. ISBN codes, actually ISBN code already in the order entity as a foreign key. Date ordered is already in the order entity. Quantity ordered is already in the order entity. Date delivered is already in the order entity. Actually, if I link, actually I don't need actually anything to be linked. If I just access the order entity, um, I can actually derive everything, isn't it? Each and every attribute is there already. Yeah, so that's the final answer for the question number 6. Does it make sense? So you need to actually revisit what we have discussed week 6. Remember the PISA delivery. There are two case studies I have discussed. PISA case study and Glenferrie Toy Library case study in my lecture, right? If you already looked at video, you may have noticed. Okay. Are you all okay with this model? Does it make sense? Yeah. Okay. So if I'm too fast, let me know. Okay. Or if you can't understand anything, just let me know. Okay. All right. That's it. Now we are moving to the next one. Okay. So that's the last one. Okay. The last question. And it's an extension of the same model again. Maybe they have changed some business rule. Who knows? Now let's read. The business narrative for the previous problem has changed for the final time. Each order may now contain many requests for many books. Many requests for many books. Okay. So earlier this order is for just for one textbook. But now an order can contain multiple requests for multiple textbooks. Alright. So each bookshop may makes an order such as this. Okay, so this is a sample order extract. So bookshop name, the date ordered. Um, this is the order number, right? Order number. Did I skip the question 6 part? Sorry. Okay, do we have second part? Yeah, examples. Okay, example. You mean this one? Okay, you can actually tell the example based on this, isn't it? I just skipped it. You can do it, yeah. Examples show the examples of data for each entity. I think it's already there. You can give a kind of an example. Authors, textbooks already there. Examples of bookshop and orders. This you can grab that information from here. Okay. Actually, example of the order entities already is the order entity example, right? And bookshop IDs already are actually the manager names are not there, but can create a kind of a different bookshops and maybe you can give some sort of fake names, right? All right. Okay. Ash, can you do that? Yeah, it's not that difficult. Yeah, at this. So, are you okay? We'll do the question number 7 and then we'll get a break and we'll do the test. Okay. So this one. Okay. So this is a sample order. What do you call purchase order? So you can see the bookshop name is there, or the bookshop ID is there, date, and the order number. And then each order can contain multiple textbooks with different quantities. Now I think, remember that we have done a kind of, if your order contains multiple items with different quantities. Remember we have done a question last lecture, if you can remember, the Glenferrie Toy Library and the pizza delivery system. Remember the pizza delivery order can have multiple items. So we have a order, what you call order line item, right? Order has multiple items, means one order can have multiple order line items. So there is a weak entity called order line items, right? So the same, it looks like the same scenario, right? Because one order can contain multiple textbooks, right? So we can have an order line item entity here. Okay. And SUNY Publishing wants to be able to produce a report such as this. So order number, bookshop number, ISBN, date ordered, quantity ordered. Okay, the entity. Okay. Right. So the same model, but there's a slight change need to be done now. Okay. So now it looks like one order. Now here, the earlier version, we have one order for one textbook. Now here, according to the new scenario, one order contains multiple textbooks, right? So one order contains multiple texts. So many to many relationship can exist between these two. Okay, many to many, right? One textbook can have appeared in multiple orders, and one order can appear multiple textbooks. So if you have many to many relationships between these two, what we need to do, we need to take that off and create a weak entity, right? That weak entity is called the order line entity, right? Order line. So we can actually do that here. So what we can do, I can remove now this one, this relationship. Okay, so let's remove this and create a weak entity in the middle. So I just create it here. Okay. So I will name this as an order line entity. So I strongly actually encourage you to watch my lecture last week. Okay, week 6 lecture I have discussed this concept. Okay, right. So okay. So if you have weak entity, we need to reverse the many ends towards the weak entity side. So now I can say, okay, one to many, one to many. Okay. Right. Now we have the order line entity. Right. Now earlier we have this bunch of attributes. So which attributes now we can shift to this entity. Okay. Order ID, can we shift the order ID from here to there? Can we shift the order ID to order line? No, right? We can keep the order ID in the same entity, right? Because one order can contain multiple line items, right? That's what it says, multiple line items. So let's keep the order ID here. Order date, can we shift the order date to here? No, right? Sorry, guy. Ash, I just saw your message. What's happened to your frozen? Is it frozen? Can you refresh it? Yeah, if it has frozen, you need to sorry, refresh. That's the problem in this uh, collaborate ultra. Sometimes it happens. All right. So that's right. So we can keep the order ID in the order entity, order date for the order entity because each order placed in a certain date. So these two can keep their quantity. Can we keep the quantity here now? Can we keep the quantity here? No. Why not? Because each order can contain multiple line items with multiple quantities, different quantities, right? Each book has different order quantities. So that means I can't keep quantity here, right? So I can take this off. I can shift it to order line entity. Yeah, this is where the quantity actually belongs. Okay. Okay, so what is this actually? Uh, I have multiple order dates here, isn't it? Yeah, I think I need to remove one. I think I made a mistake. Sorry, I need to erase this. I don't need this one. I have two order dates here. I remove this. Right, so we have order ID, order date here, and the delivery date delivered. Can I keep it here? No, right? Because item, each item, we can have multiple items, so it can be delivered in a separate date, right? This textbook maybe tomorrow, this textbook maybe 2 days after that, right? Etc. etc. So we can have different delivery date for different books. So I can shift the delivery date uh, from here. So I delete that. I take the delivery date here. Isn't it? Date delivered. Date delivered. Okay. Yeah, so that's about it. So we have now let's make this finalize. So one bookshop has multiple orders. One order is for one bookshop. Yes, that's okay. And now order, one order can contains multiple order line items, right? Uh, can contain multiple order line items. So maybe contain multiple order line items. But one order line must belongs to one order, right? And then one order line must represent one textbook. One textbook may appear in multiple order lines, right? So that's the model. So what is the primary key? So we know the primary keys of the other entities, but what is the primary key for the order line now? Anybody who can answer me? What is the primary key of the order line? I need to take the primary key of the order plus I need to take the primary key of the textbook. Right? If I can combine these two, probably it may be a perfect identifier for the order line, right? So order ID plus the ISBN code. Yeah, order ID and ISBN. We need to take both, isn't it? Order ID and ISBN because each order line has a separate what do you call a record, right? This order line item, this order, that order line item, etc., etc. Okay. So if I combine these two, it will become a perfect primary key. Yeah. So that means I need to grab identifiers from the both ends. So I can underline the relationships. So I can say here, I can just write any relationship name, order line. So order has order line items and book text. Each textbook or each order line contains or maybe has textbooks, right? So um, now can we produce this? Now you can see the date delivered is here, so it's not null. So not null. You can't have a not sorry not null. It can have null values, right? Can you see the null values here? Yeah. So don't put any null not null restriction into this column, okay? Because we can have expect null values. Yeah. So that's it, I guess. Can we produce this report now? Yes, we can produce this report order numbers coming from this order entity. Bookshop ID is also coming from the order entity because we have the foreign key here. ISBN codes probably coming from, we can grab it actually from the order line entity. It's there as a primary key. Date ordered is already there. Okay, the order entity. Quantity ordered, it's already in the order line entity. Date delivered already in the order line entity. So that means if I combine these two entities, I can easily produce this report. Okay. Does it make sense, guys? So this is my final version of the ERD diagram.